welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic structure of the atom and the periodic table, and we are going to look at ion formation. And last week we talked about cations, so today we are going to be looking at anions. So for our lesson, we will start with how anions are formed and how we can represent that in a dot and cross structure. And then you'll get a chance to do a few examples and close the session. So anions are usually negatively charged ions. In these ions, the electrons are gained to form the ion. So the number of electrons is usually higher than the number of protons. So they usually form mostly non-metallic elements. So most of the metals are the ones that react by gaining electrons in the periodic table. So examples are like chlorine. So when you look at the chlorine, the electronic enrichment will be 2.8.7. It has 17 protons and it has 17 electrons. This is in the neutral state. So it reacts by gaining. You can see it has 7 electrons in the outermost shell. So for it to add up to 8, it is easier to gain 1 electron than it is to lose 7 electrons. So the ion arrangement becomes 2.8.8 because it had gained an extra electron. So the number of protons remains the same while the number of electrons increases by 1. So they become 18 electrons. And then the net charge in this case will be -1 or 1 negative. And if you were to write the formula of the ion, it's going to be the symbol of chlorine and a negative. So let's represent this in a dot and cross. So we will start with the first shell. We start with the formula of chlorine. So the first shell has a maximum of 2 electrons. So you show those 2 electrons. The second shell has a maximum of 8 electrons. So we show those 8 electrons. And also the third shell has a maximum of 8 electrons from the ionic configuration. And then don't forget, for the ion, we said you have to put the bracket from the previous video. And we put the negative sign at the end. Let's look at another example, phosphorus. So phosphorus is atomic number 15. So the configuration will be 2.8.5. And the number of protons are going to be 15 protons when it's neutral. Electron is also 15 electrons. So when you look at the electronic configuration, we get is 2.8.5. So for this element to attain stability, it's going to gain 3 electrons. It is easier to gain 3 electrons than it is to lose 5 electrons. So it's going to gain, this is after gain. So the ion arrangement becomes 2.8.8. Then the number of protons becomes 15, they do not change. The number of electrons, since we have added 3 electrons, will become 18. And then the net charge will be 3 positive. We have added 3 negative, sorry. We have added 3 electrons. And the formula is going to be P3 minus. So if you were to present that in a dot and cross structure, then we will start with the formula, which is P at the nucleus. So the first shell can occupy 2 electrons. The second shell is occupying 8 electrons. The third shell is also occupying 8 electrons. My shell is interesting. Make sure yours is better. And we enclose these by using the brackets. And we put a 3 minus at the end. So let's do one more example, the last example. So sulfur is atomic number 16. So the configuration is going to be 2.8.6. So the neutral atom has 16 protons and 16 electrons. So when it the ion arrangement becomes 2.8.8 because you can see we have 6 electrons in the outermost shell. So it's going to gain 2 electrons. So the new number of protons becomes 16. The number of electrons now becomes 18 since it gained 2 electrons. The net charge will be 2 minus, and then the overall formula will be S 2 minus. If we were to draw this into a dot and cross, it will be S, and then the first shell will occupy 2 electrons. The second shell will occupy 8 electrons. And the third shell is going to occupy the remaining 8 electrons. And then don't forget we said you put the brackets at the end and you put the 2 minus. Just like the previous video, we said that also ion formation for an ion can be shown using the chemical symbols in an equation. An example is chlorine. This equation is different from the one that we had for cation. In that, you can see the electrons are being gained and they are on the reactant side, unlike where before we were losing electrons and putting them on the product side. So another example we have discussed is phosphorus, which gains 3 electrons. So to form the phosphide ion, we have oxygen, which reacts to gain 2 electrons to form oxide ion. We have sulfur, which also gains 2 electrons to form the sulfide ion. So next, we are going to look at some questions in regards to what we have discussed. So calculate the number of protons, electrons, neutrons, and write and draw the ionic configuration of the following ions. So protons, for the fluoride ions, it's going to have 9 protons because that is the atomic number. The number of electrons, however, are going to be different because it has gained 1 electron. So initially it had 9 electrons, but because it has gained 1, we have now a total of 10 electrons. And neutrons do not change because they are in the nucleus. So the neutrons will be 19 minus 9, which gives us 10. And if we were to draw the ionic configuration, it's going to be 2.8. 2.8 because there are 10 electrons. 2 electrons plus 8 electrons, which gives us 10. So let's draw the ion. So the fluoride ion. So we have the first 2 electrons and then the last shell. We place the rest of the electrons. Don't forget to put the brackets and put the charge at the end. In this case, we gained 1 electron, so it's 1 minus or just minus. Another example is on oxygen or oxide ion. So the number of protons of this oxide ions is going to be 8 because it's the atomic number. The number of electrons are going to change because you can see it has gained 2 electrons and it had 8 electrons before, so it becomes 10 electrons. The number of neutrons do not change because they are located in the nucleus, so it is 16 minus 8, which gives us 8. The mass number minus the number of protons. So the configuration for the ion is going to be 2.8. So if we draw that, we are going to have the oxygen in the inner nucleus, and then the first shell, we are going to have 2 electrons, and then in the next shell you have 8 electrons. Do not forget to enclose with brackets and write the charge at the end. So you do our final example, phosphorus. So the number of protons in phosphorus from the symbol is 15 from the atomic number. The number of electrons are not 15, they are more than 15 because it has gained 3 electrons, it becomes 18. So the number of neutrons remains the same. So its mass number, which is 31 minus 15, which gives us 16. And then next we look at the ionic configuration, which is going to be 2.8.8. So these 2 electrons plus this 8, then the last 8. So we have 2 shells. If we present the ion, you put P in the nucleus, and then the first energy level will take 2 electrons. The second energy level will take another 8 electrons. Do not have to use the crosses all the time. And the last energy shell is going to take the last 8 electrons. Do not forget to put the bracket at the end, the charge. So that brings us to the end of the lesson. See you in the next session.